All right, chapter 2, atomic structure. Pretty short chapter. Um, really going really quick. Not much in-depthness we have to go through. So it's a quick review on atomic structure. We're going to skip 2.1 automatically because it talks about elements. So 2.2, inside the atom. Pretty simple. We know atoms are very small. Here's a basic diagram with the nucleus in the center. Then you have an electron shell, which is called the electron cloud sometimes, which have different orbitals. And the electron is contained in those orbitals. Diameter of an atom, you got 1 times 10 to the negative 10 meters. And then the mass is 1.67 times 10 to the negative 27 kilograms. So we know it's pretty small and it weighs basically nothing. So, basic parts of an atom, we have the nucleus, which is the proton and neutron, and then the electrons are in the outer shell. So, how the electron was discovered is through J.J. Thomson's experiment with a cathode ray tube. He basically took cathode rays, which is electricity, and he used different coils to project or to deflect the electrons towards the positive end of your magnet. And he can come up with the weight to charge ratio using the cathode ray. There's a YouTube video on Learn that goes into more in depth of the cathode ray tube experiment. So basically you have subatomic particles, and to determine the charge, you take a positive charge field or ray, and then you deflect it with magnets, so you would see that would go down because opposites attract towards the negative. You did the same thing, but with the electron, it would shoot up because it goes towards the positive, negative. And then if you have a neutral neutron, and it would go straight through because there's no charge on a neutron. So, a beam of electrons is passing closely to a highly negative charged plate. Uh-oh! When the electrons pass close to the plate, they are deflected away from the plate. What deflection would you expect, if any, when the experiment is repeated with beams of I protons and 2I neutrons? Well, if you guessed that they would be deflected towards the plate, then you are correct, because protons are positive and they will deflect really close towards a negative charged plate. If you said nothing would happen with neutrons, then you are also correct as well, because neutrons are not charged. Therefore, any magnet or negative charge, positive charge plate will do no harm to the neutron. Part B. Which subatomic particle would be deviated the most, and why? Well, we know the neutron won't be deviated at all, so that's thrown out. So it depends on the proton and electron. Well, if you are thinking the electron, you are correct. And the reason why is because of its mass. Electrons basically weigh nothing, and protons are heavier than electrons. So, for example, something that's lighter will cause a bigger deflection than something that's heavier. Think of a football player. If you have a football player who's light, say a kicker, he can be pushed around. You think something heavier, like an offensive lineman, a little tougher to push around. So the lighter one will deflect more. And here's that data. We know protons are positive, neutrons are 0, electrons are negative. And then look at the mass difference. So the relative mass of protons and neutrons are the same, about 1, but electron is 5.45 times 10 to the negative 4 AMUs. So you can see it weighs a lot less. Symbols P, N, and E negative for electron. 2.3, nucleus, neutrons, the nucleon. Pretty simple. We reviewed this a little bit in chapter 1. But the proton number is the same as the atomic number and the same as the number of electrons if it's neutral. This defines the element, the protons. So if you have 11 protons, you have to be sodium. If you change the protons, you change the element. Periodic table is arranged by number of protons, and the mass number, which is the nucleon number, is the protons and the neutrons together, because that makes up most of the mass of an atom. Here's a way to write the symbols. We went over this. Mass numbers on top, that's the protons. Sorry, mass number, right, mass number is the protons and neutrons on top. The atomic number, the number of protons on the bottom left, and then the element symbol as X. So, how do we determine the number of electrons and neutrons in these neutral atoms? Well, the neutral atom defines as the same number of protons, which is for vanadium, we have vanadium 51, there's 23 electrons. To find the neutrons, you just have to subtract the protons from the mass number, and you get 28. 28 plus 23 gives you 51. Strontium 84, electrons the same number, so it would be 38 electrons, and subtract 84 and 38, you get 46. And phosphorus 31, we know it's going to be 15 electrons and then 16 neutrons, because 15 plus 16 gives you 31. Isotopes, same number of protons, different neutrons, because they have different masses. You can write two ways to write a element. You can write in the stack formula, 11 over 5 in the formula for the symbol B, or boron 11 also tells me that boron is the element with the mass number of 11. Here are some examples of other isotopes. We have hydrogen, we have deuterium and tritium. You can see in H1 is only one proton, H2 is a proton and neutron, and H3 is two neutrons, one proton. Helium has two protons. You have He3, one neutron and two protons, and He4, which is two protons and two neutrons. And then you can see lithium is Li6 and Li7. Again, the neutrons are changing, but the protons are staying the same. How many protons, neutrons, and electrons? A little simple math. Neutral atom has the same number of protons and neutrons. So for example here we have lithium, because it's plus 3, and negative 3 gives you 0. How do you become a charged particle? Is by either gaining or losing electrons. Metals always lose, and non-metals always gain. You can see in this example, sodium has one electron in the outer shell. They lose an electron, therefore it becomes an ion with 10 electrons and 11 protons, gives you a +1 charge. Here chlorine has 7 in the outer shell, gains an electron, now it has 8 for a total of 18 electrons, 17 protons, so it's a -1 charge. Metals become positive, non-metals become negative. You can see in this example, chlorine gains an electron, so it goes from 17 protons with 17 electrons, gains an electron, so it's 18 electrons, which should be negative, and you get Cl -1. Magnesium is a metal. They lose electrons. Starts off with 12 protons, 12 electrons, and then it has 12 protons and 10 electrons, so it has a +2 charge. Notice the protons stay the same, only thing changes is the electrons. Last problem, determine the number of electrons each. So potassium plus 1 means it lost an electron. So it goes from 19, because 19 is the proton number. So it would go to 18 electrons. Nitrogen 3 negative starts at 7, goes to 10 because it's 3. Oxygen has 8, gains 2 more, so 10 electrons. Gallium 31 has a plus 3 charge, that means it loses 3, so it went to 28 electrons. If you have any questions, let me know in class.